So let's talk about the solutions we have with our Galaxy implementation platform, which leads the market in terms of implementation. I wanted to specifically talk about the look-ahead technology that we had in this, where synthesis can feed information into placement, placement can feed information into routing, routing into design rule violation checking, into timing analysis, and so forth. And what the look-ahead technology allows us to do is to monotonically converge on the solution and to avoid surprises. It lets designers of these chips very rapidly implement the technology in a fast time to market. But in addition to time to market, it's also very important to focus on system cost. And some of the best features in the implementation tools that are actually designed for FinFET are having tremendous advantage in the Internet of Things as well. Let me give you two examples. In one case, we're able to reduce the number of metal layers in a chip by 2 metal layers, and in another case, we're able to reduce the total area by 10%. And that resulted in a significant system cost reduction for the IoT applications that the customers were working on. So James, there's not just a lot of innovation going on in the implementation tools space. The foundries are innovating in the process space as well. Tell us about some of the things that our ecosystem partners are working on.
John, in our early conversation, we talked about one of the biggest challenges of designing Internet of Things kind of a product is really energy efficiency. So the foundry are now all coming up with new process technology options in 55 nanometer, 14 nanometer, and 20 nanometer with lower supply voltage, trying to achieve a better energy efficiency as a goal. For example, some of the process node you can reduce from the 1.2 volt down to 0.9 volt as a detailed information, but those are the examples that our IP need to re-optimize and take advantage of new options like that.
So James, as you know, we actually have a very robust family of IP for Internet of Things applications. One of the areas that we focus on is having very power and performance efficient and area efficient processors. Tell us a little bit about the ARC family.
Currently, we have two subfamily addressing different application in the IoT market. For the lower end of the market, we have a EM family with DSP extension that can address sensor data processing kind of applications. In the higher end of the market, we have a HS family that has a better performance capabilities to address the embedded Linux applications.
So James, one of the other product lines that we have is a sensor and control subsystem. Tell us a little bit about the key features of that.
The key features is really try to integrate peripheries, and so such that we can optimize from power consumption perspective. We can optimize latencies. We optimize the area. The area is as small as 0.01 millimeter square. And that way we can deliver a very optimized solution to the market.
And we've also worked very closely with software partners, for example, Hillcrest Laboratories and Sensory, to have a complete hardware-software solution for the sensor subsystem.
That's right.
So James, another area of our IP portfolio is foundation IP, embedded memory and logic libraries, and we've done a lot of optimization on those families to address the Internet of Things. Please tell me a little bit more about that.
One of the critical things is for IoT application is being primarily designed in a so-called established node. We have standard cell library and embedded memories for those technology nodes for a very long time, but we're not trying to relabel our existing IP to address the market requirement. We're really using the latest technology and techniques to optimize, support the lower supply voltage, and using cyclic oxide library to enable the low power solutions.
Along with ultra-high density libraries as well. So at the beginning, we talked about three major challenges that our customers face in terms of security, integration, and interoperability. And our verification tools actually address all of those challenges. So we have tools that focus on the latest in low-power verification techniques, the latest in analog mixed-signal verification techniques. In addition, we have solutions that allow designers to bring up software in parallel with hardware, thereby finding some potential problems that may cause the device to go into a very high power state or never exit a state and thereby waste power. So one of the other challenges that Internet of Things designers face is creating software early. The number of power domains that the software has to manage is very, very significant. And so, for example, we have tools that help our customers bring up the software concurrently with the hardware, as well as provide solutions to bring up software early, well in advance of the actual chip being manufactured, so difficult power states can be analyzed and we can make sure that the device is not going into a state where it's burning a significant amount of power or behaving in some way that's not expected by the user. So talking about software, James, as you know, Synopsys recently acquired a company called Coverity to get into the software quality and security space. And most of these embedded applications are being written in C or C++ still, but increasingly they're being written in new languages like Java or C#. And Coverity provides tools to analyze software for both quality defects as well as security defects. So specifically, we have tools called Coverity Quality Advisor and Coverity Security Advisor that make sure that the software that our customers are developing is both of high quality and high security. So James, we talked about some of the challenges in the Internet of Things, and we also talked about the broad range of solutions that Synopsys has, everything from silicon to software. This is clearly a fast-moving market. How do you see it evolving over the next couple of years?
John, currently industry is really in the early innovation stage, and the ideas and the product come to the market today will not be the same product 3 years from now. So the key of Synopsys value proposition is with especially our optimized IP portfolio, we can enable our customers to design their product in a very fast time to market perspective.
Synopsys has a very robust portfolio of solutions for the Internet of Things, everything from implementation to verification to hardware-software development to IP to software quality and security that will really enable our customers to get to market quickly.
Absolutely, John.
Thank you for watching.